rotate it the way it was. And the look quad, which was a quaternion, which we obtained using this look rotation method. So this function allows us, like here in the hint is telling you, allows us to create a rotation with a specified forward and upwards direction, or just forwards in this case. So this look vector we obtained by taking the target position and subtracting it from our start position, so the actual object that we're rotating. So we find this direction vector. You should remember that. So this was just a vector subtraction, and we got a directed vector pointing from our starting point to, in this case, the player or look target. So this is all great, but now we'd like to incorporate this functionality into the turret itself. So let's do a little bit of creative copy and pasting. That's not a bad way to do it. So I'm gonna have turret controller here on the left hand side of the screen and look at target here on the right hand side. First of all, I need to track the player by the turret. So the turret needs to have some knowledge about where the player is. So let's create another, we can make it a private variable of type transform. Let's call it aim target. Okay. And let's assign it at the very beginning. So I'm just going to take what I had in look at target in start. Okay, great. The only thing is I renamed it to aim target, so I have to rename it here as well. Let's do that. What's happening here? If the aim target, well, if it's null, which it will be in the beginning, then I'm going to use the find with tag method to find an object in the scene which has the tag player. So this is the function we're starting with, find with tag. Obviously now I've removed the transform field. I have a mismatch, so this is of type. The result of this is going to be of type game object, and I'm looking for something of type transform. So yes, once I find the player, this will give me the game object that is associated with the player, but I need to then use our magical dot notation again and grab the actual transform. So here, IntelliSense to your rescue. If you want to see what you get, type the dot, and then you can see what's out there and select transform, for example. Cool. So we have aim target assigned. Now we can start copying and pasting some of the other code. We probably need this vector as well. So, but let's do it slightly differently. Let's create a variable here. So private aim vector. Okay, I forgot the type. Vector 3. Okay. And at the very, well, actually no, it needs to be updated every frame because the player might be moving relative to the turret. So I'm gonna copy this because we've already written it before. So so the look target, okay, we've renamed that to aim target, okay, and transform position aim vec. Aim vector. Does anything seem strange or suspicious here at this stage? Okay, well, okay, we'll see. We might be running into a problem, but well, let's carry on. So in update, what else do we need to do? Well, we need our rotation to rotate the turret to. So let's just copy this code because we've already written it before, so let's stick that into the update function of the turret controller. Let's call it aim_quat, quaternion look rotation aim vector. Okay. And now we want to transform rotation. Okay, we'd like to see, I've copied this code from the look at target, and remember what we were doing, the interpolator was handled by the game controller, so it was something that was a global variable, like a static variable that we accessed from somewhere else. Only one for the whole level, only one for this particular scene. So I don't want this to be done this way anymore. I want this interpolator, this variable between 0 and 1, which tells me whether the turret is pointing at the player or not, or is it at its original rotation. So I'm going to create this private variable. Actually, for the time being, let's make it public. We'll change it later. So public float interpolator. And let's give it a default value of 1. Okay. And we're going to use this in our linear interpolation. So again, between there are 3 parameters to this quaternion slurp. So this is to give us a rotation that is somewhere between 2 extreme values, right? So the minimum value when interpolator is equal 0 should be quaternion identity, and when the interpolator is equal to 1, this is going to be our aim_quat. So this is going to be our should be aiming at our player at least. So let's save and let's see if it actually works. Oh, by the way, is the stream any better now? I think I had something in the background which, okay, great. Sorry about that then. Actually, silly me, this was the, yeah, okay, great. Thank you. So let's see what happens now. Okay, so this is still doing its weird rotation, but that's why, because we haven't removed the old component look at target. So I'm going to do that now. I'm going to remove this from the gun, and I'm going to remove it from the slit dome. Okay, this is actually, this is a prefab, so well, let's just update the prefab. I'm going to drag this here, and that should take care of it. Okay. Okay, so probably not what we're looking for. The whole turret is now rotating, so this is a bit satirical. Where did we go wrong? Anyone? Okay, where we went wrong is for our aim vector. Let's have a close look what we used. We used our aim target position. Well, okay, that is the player, so this is correct. But here we use transform position, and this is the transform. What point is this actually? Where are we actually starting our vector from? Well, if you have a look at it in scene, you see that it's actually at the base of the turret. So that's one problem. So obviously we need to do something about it. So what we need to be rotating in this case is the gun. So let's go again to the beginning. Public transform gun transform. Okay, and we will need to assign it in scene. Cool. So gun transform, I'm gonna just drag this into the slot and it should be okay. What else do we need to rotate? Let's think about it. Well, the dome as well, so let's add another transform. Okay, and let's assign that. One thing to keep in mind in here is that, okay, we're dealing with prefabs, so I just highlight this prefab. Okay, sorry, okay, must have been a hotkey, thank you. So this is the actual prefab. I opened the prefab. Normally you cannot really drag transforms from elsewhere in the scene into your prefab. You need to get that distinction that the prefab is something, it's an asset, it functions outside of the scene, and you cannot refer to a specific scene because it might just not be there, might not be open. We might be in a different scene when we spawn the prefab. So it makes no sense to bind it with anything that's actually in the scene. But in this case we have something which is underneath the hostile turret, which is the kind of root object. So in this case there's no problem, we can drag this into the prefab and then okay, sorry, I didn't open it. Okay, now I'm in the prefab, and I'm gonna assign the gun transform there and the dome transform. And once I'm done, I go back from the prefab. Okay, so this should already be there. So so let's do something with our new variables. In this case, obviously aim target, and we need the gun transform. The center of the gun is going to be where we are targeting from. Cool. Okay, and then also when we rotate, we don't want to rotate the whole turret, we want to just rotate the gun transform. Okay, so now keep in mind that the interpolator is set to 1, so this kind of basically makes it immediate. Now the turret, the gun itself is following the player as it should, so well, that's nothing new, of course, we've done that before, but it's good to repeat sometimes to just reinforce some things. We also need to rotate the dome, so to do that I'll just copy this last line of code. I'm gonna say dome transform rotation. Yep. Only in this case the aim quaternion is gonna be different. I need a separate quaternion for this. Yes. So quaternion dome quat. We've done this before as well. Only in this case the aim vector needs to be modified. We zero out the y field. So now we're kind of only targeting in the horizontal plane. We've gone through this before. So our vector is no longer pointing any whichever direction. We've zeroed the y transform, so it's always going to be something in the plane. So we create another quaternion using this aim vector, modified aim vector, and we apply this rotation. Also using the interpolator, same as before, only now we use the dome quad. Okay, so right, you see, we've created this new quaternion to define our rotation. We use the aim vector, but this time the aim vector is not going from the position of the target, from the gun to the target. It's something that's on the horizontal plane. So save and let's try and let's see what happens. Okay, so both the dome and the gun are not behaving as they should. That's great. Okay. Progress. Okay, what else do we need to do here to make this more like a game? Okay, we'd like to start shooting some bullets, so let's get busy with that. Let's create a template for our bullet. So right click on the top node, create a new object, 3D object, sphere. Let's call it bullet. Let's give it a small size, maybe 0.1 on all axes. Okay, it's a little bit, okay, it's at the center of the origin of the coordinate system, so okay, but I can, alright, let's pull it out so that we can have a closer look at that bullet. Well, it's not very visible, right? We need something that's more obvious. So let's make a new material for this bullet. So let's go into our materials folder, right click, create new material. Let's call it bullet. Okay. And let's use the standard shader for this material, that's fine. Let's give it albedo of maybe a red color. Okay, so let's just assign the new material. We will work, we're not finished with this material, but let's assign that already. So I'm going to assign this just to the bullet there. And let's see, okay, so this bullet again, we want something like an energy plasma bolt. So this is dependent on the lighting, right? Our directional light is on, so I'm going to disable that, and now I kind of don't see anything at all. The city lights, if I disable that, I have a black dot, I don't even see it, so that's not really good for our purpose. So I have a question for you. When you create a material, what property of the material should I use for our bullet that would make it visible in regardless of lighting conditions? Any ideas? Okay, well, whenever you want something that is self-illuminated, basically always has some kind of a bright color, you use the emissive component. So emission, you can find this here in the material, okay, and let's assign some color that is not black. So let's make it orangey, something like this. And that already gives us a decent enough effect, and this will be visible regardless of what is there or not in scene, so self-illuminating. Okay, cool, so we have the appearance of our bullet, that's fine. Let's move it back to 0 because we don't need that causing a problem later on. and like just start working on the script for this bullet. So let's call this bullet. Okay. Is John? Yeah, no problem. Of course. Okay, this bit, the second quaternion. Okay, yeah, I'm gonna give it like a, because yeah, this might be a little bit. Let me just regroup. So the effect we want at the end is rotate the turret in a specific direction. So let's start from the end actually. So the dome transform rotation. Here we assign it, and you know this should be the rotation that specifies the direction toward the player. Yet we don't want to rotate. We don't want to pitch or roll. We just want to rotate in the yaw. We just want to basically change the heading, but not the elevation or not the roll. So in this case, the way we did it is we started with the same vector that we had for aiming the gun. Is this bit clear? The first quaternion? The whole structure, is that something that is unclear, or it's still unclear? Okay, no problem. So yeah, okay, so we need a, okay, cool. I took the same vector that I had. Okay, maybe let me I wonder if I could show you some other way. Let's see. Let's look at the scene. Okay, let me just make it a little larger. Okay. Maybe not that easy to show, but okay, this is like a 3D, let's say this is a 3D view. I'm going to go with maybe wireframe. So this is our center of our gun. This is the player location in 3D. The vector that we're looking for is going basically from here to here. So it's the line between this point and this point. And it's in 3 dimensions. It has if I look at the front view, I can see that this vector goes from this point here, and it has a certain y component. What happens if I remove that y component from the same vector? I'm going to get the same vector, only flat, lying on the horizontal surface. So it's going to look the same from top. It's going to have the same x and z components, but once I clear y, I've just lost the information about the vertical side of it. So this is better. So So if you imagine a straight line connecting the player and the gun, we've just modified this vector by flattening it into the horizontal plane. This is the bit. Okay, this is the bit here. So we took a value which was a three-dimensional vector, and we just zeroed one of the dimensions. So now it's kind of effectively a two-dimensional vector in the x and z plane. So the rotation would be just a rotation towards something which is in the same plane as the dome, and the result is that it only rotates kind of horizontally. So this is what we were wanting this. Does this make it clear? Okay, thanks. Alright, so let's carry on. Back to the bullet. Back to the bullet, and we have our new script, which doesn't do much. First of all, we would like to probably be shooting a lot of those bullets very frequently, very quickly, and we don't want this to get out of hand. We suddenly don't want to have too many objects in our scene that might, let's say, crash our engine. So let's do it a simple way. Let's just use a destroy function. It has a pretty useful property. It seems a bit funny that we're just starting here in our bullet script and we're just asking it to destroy itself. But there is a overload to the destroy function, number 2, which actually gives you an additional float t. Here, t, the optional amount of time to delay before destroying the object. So that will actually do the trick. I'm going to say 7 seconds. 7.0 f, right? F for float. Or you can say 7f, that's also acceptable. And now our bullet is going to die always after 7 seconds. So if we're too far for the bullet to even reach us in 7 seconds, too bad. So this is how we're going to handle this. Let's save this and let's complete our prefab, because we pretty much have everything we need for the bullet now. The script is not complete yet, but we can already prefab it. So I'm going to go to prefabs folder, grab the bullet, drag it there. I have a new prefab. All good, singing, dancing, delete the bullet from the scene, fine. But now I will be spawning those bullets by the turret. So let's just go to our our turret controller, and let's add a reference. So public game object bullet prefab. Okay, and we can assign that to our. You can also use transform, that would also work. But public game object bullet prefab. Let's give it a chance to update and drag your bullet prefab in. And now we can start playing with instantiating it. Okay. So that's good. Step by step, we're getting closer. How do we handle the bullet movement? Now, this is this is a little bit up to the programmer. Are we going to have the turret decide what direction to shoot the bullet in? or is the bullet smart enough to figure it out? Well, we're not writing a class for tracking missile, so it doesn't really make that much difference. I think the simpler way to do it is here in the bullet class itself. So again, the bullet would have to know the player's location. So we've already done it several times over. Let's do it once again just for this class. So at this stage I'm just kind of copy and pasting this. Let's say aim target. I take this from the target controller into main class. I have this private transform aim target. I will need the player, so I'm going to grab this code as well. If aim target is not null, is null, then assign it, find it with tag. This makes actually more sense because public transform to the player in a prefab wouldn't make sense, because again, this is outside of the prefab and it's something that's tied to the scene. We cannot assign it up front, so we do need to do it at real time. Once we start, we need to assign this in start function. So now we know the position, and then we need to do something else. We also need a vector. Yep. Slow down, or okay, maybe it looks like no. This is equal. So this means equivalent. This means it is the same. The other one you have is the opposite of it, is not equal. So these are logical operators. Actually, maybe a good time to remind that Microsoft C# reference. I'm going to send you the link as well for your self-study as well. So C# docs get started tutorials reference. Let me find this for you and see where to look for things like that. Okay. C# operators. So equality. I'll just send this link on. Sorry. So this is described at length there. If you need a kind of a more detailed spiel. But all the logical operators and assignment, well, yeah, logical operators, conditionals are here. It's good to be aware of them. Mostly we will be only using and, or, equality. Okay, so in this case, this is to check that in the beginning, if this hasn't been assigned before, because well, potentially it could be. If you don't use this in a prefab, just put it somewhere in scene, you could assign it by hand. But otherwise, if this hasn't been assigned in inspector, then do this. Use this find with tag and assign the transform of that object. So yeah. Okay. So now we know the starting. We know the bullet is aware of the player. So we could actually make more fun things later on, like actually make a guided missile. But at the moment, let's not go over the top. We will need a vector to determine the starting direction. So let's actually make this a private field, vector 3, and aim vector, yeah, or maybe direction. Let's just call this start direction, just to be clear. And again, start direction, assuming that we instantiate our bullet in the right place already, then we can just use its transform position. So in this case, I copied a bit of code there just to kind of make it maybe faster and avoid errors, but start direction is equal aim target position minus, and here we need to go back to transform position, because this is our bullet's position, so this should all work. Okay. The only thing though, well, let's see. We need to update the position of the bullet. So let's do that in the update function. Transform position. What type is the transform position field? This is a vector 3. I can use operators like increment on this, so I'm going to do plus equals, and I'm going to add some vector to it. So the start direction vector that I just came up with, I'm going to use that. But obviously this is too much. Like this would just send the bullet flying very fast. Yes, toward the player. Yes, Shashank? Okay, thank you. Thanks a minute. Okay, so transform position, we increment this by the start direction vector. We would like this to be independent of the frame rate, so we will multiply it by a fraction time dot delta time. So this is the fraction of the second taken since the last frame, so this is going to smooth out our frame rate problems. But also we need to provide a way to specify the speed of the bullet. So I'm going to make a public float speed and default value, whatever, let's go with 10. And I'm going to multiply that as well. This is legit because okay, this is a vector 3, this is a float, and this is a float. If you recall, a vector can be multiplied by a float value. Let's say we have a vector. This just shortens it or extends it. Depends on whether the float value is 1. This multiplying by 1 leaves the vector wherever it is in 3D space. Multiplying by half is going to just create a vector which is half the length but the same direction, and multiplying it by a large value is just going to create a much longer vector. So this should be very clear to you by now. So let's see if that works. We have our direction, yeah. Okay. Okay, but of course nothing is happening because we haven't actually instanced the bullet. So let's do that. Okay, so in the target controller, okay, yeah, I've gone a little bit ahead of myself, but okay, let's have a look at the target controller. Is it possible that you still have something on the gun or on the slit dome? If you have a look at still on any of these objects, then this would interfere with our rotation. So check that. Okay, so let's put our on trigger enter and on trigger exit into play. So in update, I'd like to in turret controller, if alerted, I'm just gonna instantiate the bullet. I need to specify the position, so this would be the gun transform position. I'm spawning it in the middle of the gun turret. And then rotation would be, we don't care, so quaternion identity. Okay, and let's try that. So this will shoot a bullet every frame as long as we're in the area of the turret. And this is what's happening. Okay, additionally, okay, what I've done is kind of made it quite destructive, because what I wanted is to just use collider triggers. So let me go to my bullet prefab. I'll open the bullet prefab and I'll just set this to is trigger. So this will be a little bit different. The bullets won't be so destructive anymore. But that's just because I don't want things to get too messy. And yeah, so right now the bullets are actually flying through the buildings because it's just a trigger collider. It doesn't actually physically collide with anything. Okay, but this is a little bit rubbish, because if I'm within the area, then immediately the turret is pointing toward the player. So this is rubbish. So I need to do something better. And how do I do it? Well, remember that we have this interpolator value that we haven't used so far. We've just set it to 1 and we left it at that. That's not good enough. So instead we're gonna take this instantiate. For the moment, I'm gonna just work around it. So if alerted, I'd like to interpolate the value. So interpolator. Now this bit, we've done this again. So this is very similar to the rotation bit. We're also lerping. Lerp is your friend. Lerp takes 3 values. It takes A, B, and T, so linearly it interpolates between A and B by T. So our A value is going to be our current value of interpolator, whatever it is, whichever way the turret is pointing now, because we have to get the sense that for 0, the turret is pointing at whatever original orientation it was at. For 1, it is pointing at the player. So between interpolator and 1, because this is supposed to be happening when alerted, and then some kind of value, so 0.1 F maybe, or 0.2 F. Okay. So this is going to happen when the interpolator, when we're entering the zone. If alerted, right? If alerted. So this is an if-else structure. I'm going to add an else statement. So in the other case, I'm going to interpolate towards 0. So this is again smoothing the rotation. smoothing the interpolator value, but towards 0 this time. Okay, and I'd like to do something extra here. Which is, I only like to start shooting when the interpolator has reached the value of 0.9. So when the gun turret is almost pointing at us, I'd like to already start shooting. So I'm going to add the conditional here. So if interpolator is less than 0.9, then do this. Sorry. I shouldn't be using insert. Yeah, sorry. Cool. So let's see how that works. Is the bit with interpolation making sense to you, or should I go more in depth with that? Edit. Sorry, okay, sure. That's where we're at. So if alerted, I increase the interpolator value toward 1. Eventually it will get very closer to 1. If not alerted, so if we are outside, then we are actually moving the gun turret away. So, but the next thing is, if the interpolator is already larger than, oh sorry, I actually made a mistake here. So this needs to be larger than 9, yeah, larger than 0.9. Let's try that and see what it does. See? Okay, so there's now a proper rotation animation. It's a little bit fast, so let's do something about it. I'd like to actually specify this value here, 0.2. You can get the feeling that this is a little bit arbitrary. I just picked it, and it might actually be dependent on frame rate as well, what's happening there. So let's make it a little bit more explicit. So public gun speed on, and default value 0.2 is grand. Okay, and gun speed off. I'm gonna vary it. It's a float. Thank you, IntelliSense. Okay, so I'm gonna make this value much smaller, 0.025. And now I have errors somewhere else. Well, no, I don't. But I'm gonna use this value that I created now for this interpolator. And the off value in this interpolation. Okay, shoot. And additionally, okay, I need to, not that's grand. So very fast when it notices you, it goes immediately into position. Meanwhile, if we move away, it does a kind of a lazy come back to original. Okay. Okay, so this is making it a little bit harder for the player, because if we go back in and forth between the zone, yeah. Okay, so that's a kind of a rudimentary approach to this detection. But now we want to do something more with the bullet maybe. So, well, first of all, we know that the bullet has a collider trigger on it. So we can use, on the bullet, we can use the on trigger enter. We only really need the on trigger enter, and we're only interested in that. Let's write something to the console. Debug log hit. Not very exciting. I know we can, maybe if we have time we can work with a little bit of sound, add a little bit of sound to it. Okay, cool. So now if we go switch to console, you can see that the amount of messages here is continually growing. So we're spamming the console with those hit messages. So this is working okay, the detection is there, but we don't want the bullet to just fly through. We actually want to destroy it. So we're going to destroy this game object. So this bullet will destroy itself if this callback if this event happens. Okay, maybe it's going to be time to take a little break soon. Let's see. Let's carry on for a little longer. Okay. So now you can see that some of the bullets at least, well, it's hard to say. There's a problem. The bullets are flying so fast you can actually see it on the screen that they sometimes pass the player and they don't even hit, because between one keyframe and another the bullet has moved so far that you know, it's a little bit strange. Meanwhile, if I move closer to the player, to the turret. Okay, now I'm sitting right in the nozzle. Okay. We get somewhat close to this. Okay. It's still going super fast. Let me try it again. Sorry, I'm just trying to show something here. Yeah, it's a little bit better if we're close. So this distance from the player, we don't really want it to be affecting how fast the bullet is flying. If you get the sense, inside bullet, now we add something, we multiply the start direction that we got from the position of the player and the gun turret by the time and speed. But this is a vector that can have different magnitude depending on the conditions. So actually, let's do an additional step here. Well, you can do it this way. Go to start direction in the update, yeah, and just use the normalized field. So this is actually gonna give you a normalized unit length vector. So this will equalize the situation depending on regardless of the distance between the target and the start point. Okay, so we see something change, definitely. And most of the bullets are actually hitting the player and disappearing. So this is making me happier. So that's great. So let's carry on. With a little bit of theory. Let's make this a little bit more elaborate now. If you see in the scene now, if I am within the zone, if the detection is happening, but I'm behind a building, it's still shooting, and this is probably not what we want. Also, another thing that we noticed, the hit is being still activated, but we're not hitting the player, we're hitting the building. So that's not correct. So we need to make this a little bit more specific again. Remember how we did it in the target controller? If other tag is equal player. I'm going to do the same thing here. Only that's more than one command, more than one line of code, so I need to bracket it. Okay, so that takes care of this. Okay, and see, even though I'm behind the building, it's still shooting, only disappearing when you hit the player, but that's probably not what you want either. Well, one way to do this would be to actually use a raycast. So shoot a straight line from the gun toward the player and see which is the object that we hit first. So this is what raycasting is about. A general overview here. So we do a physics raycast. The raycast is in the domain of physics. It's using the colliders to determine which objects the line hits. We need to specify the point of origin, so where we start our ray, and then direction into which we're shooting our ray. Also maximum distance, where we want to maybe limit our search. We can make it infinite. This makes it work regardless of how far the collider is. And layer mask, so we'll get to this as well. This is we're getting into the interesting bits of today's lecture actually. So for raycasting, we're casting a ray against all colliders in the scene, and this raycast is going to return true or false, depending on whether it intersects with the collider, that line intersects or not. Optionally, you can use a layer mask. So we're getting to the layers soon. At the moment, let's just use this little bit of sample code that I have in the presentation. So in the target controller now, where we have this interpolator larger than 0.9, I'm going to comment this, so /*, like I said before, and then */ comment it out, and I'm going to paste this little bit of code from the presentation just to make it easier. So we declare a variable hit of type raycast hit, and then do a physics raycast. We know that this whole thing returns a value of type bool, so true or false, so whether we hit something or not. So if we hit something, we specify the transform position. So this is our start position. Where do we start our raycast from? Do we start it from transform? Well, no, because we know that this is the base of our target. We want the gun transform. And the direction? Well, maybe we can just use, because the gun is already rotated the way we want it, right? So I'm going to use forward direction of that. And now this is the hit variable. So this value will be assigned here. That's what the out keyword means, that this argument is of the output type. So we're providing this to the raycast function, and we expect the function to change this value for us. This is how it works. So yes, we have the Boolean return value, but we can also get some extra information by specifying this hit value. Math f infinity is just the way to specify infinity. And layer mask, well, I'll get to this in a second. I'm going to rename it to raycast mask. And I'm going to actually create a variable for it. And we'll get to it just really soon. So public raycast, layer mask, raycast mask. Okay. So yeah, we have the did hit. Okay. We don't. Yeah. Let's just go straight to instantiating the bullet if that's true. Okay. I'm gonna actually remove it. We don't need it anymore, just for clarity. Oh, okay, I think I had the wrong screen there. Sorry for that. So, this is what I did here in interpolator, third controller. So, physics raycast. I added the gun transform position as a start point for a raycast, the forward direction of the gun transform, small, camel case. So before I proceed, does that answer your question? We're actually done with the bullet, I think, for now. Okay, cool. So I'm gonna max it out. Well, you can see what happens now. In the hostile turret, now we have this extra variable layer raycast mask. We haven't used layers so far. What are layers? Have you used layers before in Unity? It's not unlike layers in Photoshop, say, or lots of other software. It's a way to group together objects which have similar properties. I have a couple of slides about layers, but maybe without going too much detail. They can be used for rendering, so cameras work with masks, work with layers, but also can be used for physics. So let's have a quick look at this, at layers, before we proceed. Unity provides some default layers for you, but we can create more. So the layers 0 to 7 are special, the ones Unity uses. But let's say we create a new one. So it's a little bit like tags. So it's even bundled together with tags and layers. So on any objects in Inspector, it doesn't matter. You can here go to layers, add a layer, and let's add player. Let's make one layer called player. Machinery, that's the second one. Buildings, and maybe bullets. So yeah, let's leave it at that. And at this stage, I think player has default layer. I'm gonna set player to layer player. Yes, change children. So this makes does the hard work for you. All the objects underneath. All the objects underneath are set to the layer for you. Hostile turret, yeah, let's call this machinery. I'll explain why we do that later. Let's go into our prefabs. Hostile block is the one we use for the city buildings. So I'm going to open this, go to layer, and set it to buildings. And save that prefab. Last one is the bullet. So open prefab, layer, bullets. and exit. So this takes care of that. So we assigned some layers, and now we can play around with this a little bit. Let's say I said that layers are used sometimes for rendering. So let's try that. Main camera. Our cameras have what's called culling masks. So there's a link to a short tutorial there. So sometimes we need more than one camera in scene, for example, and we can have one camera rendering certain elements on some layer and another camera rendering something else. So this is an example. Let's say I'll change the culling masks of the main camera to not include machinery, and the turret disappears. Okay, we can select whatever we. So if I remove default, everything nearly is gone now. I'll bring back machinery, and now I see only the turret, right? So everything is what you typically would have in the camera culling mask. So this is using layers for rendering, but you can also use it for physics, and I'm going to get to that now. So we'll go back to our hostile turret and open our raycast mask. And now we will just select the player and buildings. So it's a mixed raycast mask. We can select several layers. So this is why it's called a mask. It's a collection of layers that we use together. So why do we need to do this? Okay, we do our raycast between the gun and the player, and we'd only like to consider the objects which are on certain layer. We don't want, for example, to raycast and find that we've collided with the turret, which could happen because we're starting from the inside of a gun. There might be a bit of the collider of the dome that we hit, and we don't want that kind of detected. So we're just going to focus on the player layer and the buildings layer for this. So this is already in. So let's try it. I think this is actually going to work. Okay, and let's see. Oh, it's still shooting at us. Oh, that's not good. Let's see if this is properly assigned its layer. It's got layer building. Okay, so that's okay. So what's happened there? Okay, because I didn't add this specification. So now this is. Mask. Let me check that again. I have a mixed mask which has player and buildings. Okay. Okay, it still keeps shooting because instead of a player, it's hitting a building. So okay, pardon me. So I only want to be shooting if this returns, if the raycast returns tells me that you've hit the player. So to do that is we have to use this hit variable that we've created. So let's type hit and see what we actually get there. Dot. So let's see what we have, and we see that we receive a collider. That's fine, that works for us. We can use the collider. What does the collider give us so that we can search further? Dot. Maybe we have a tag. Great, we're done. So we need to have a if statement. If the collider tag is equal to what? By now it should be quite a reflex for you. So player. Then we instantiate this, and that should do the job for us. Okay, so we've hidden behind the building and it stopped shooting. It's still tracking us, mind you, but it stopped shooting. So, yep, that's an improvement. Okay. How do you feel about the break? Do you need a break? Do we carry on and finish earlier? Well, if you don't respond, I'll just carry on. Break, please. Okay, let's have a break. Cool. Let's take a break until 3:34, please. And I'll start in 10 minutes. Sure, I can do that. Okay, this bit with triggers should be quite clear. This bit we talked about. Is this enough? Let me fit it a little bit more on the screen. Cool, okay, sure. Okay, there you go.